We define the hyperbola like this. It's the locus of a point. The difference of whose distances from two fixed points is always constant. Let's use that definition to figure out what that difference really is. Let's mark some points. These two are the foci. Let's take this and this vertex. This is a comma 0. This is minus a comma 0. Let's mark these points P1 and P2. Let's mark the focus as well. This is F1. Let's mark this other focus. This is F2. Now the definition of hyperbola says that the difference remains constant wherever you are on the hyperbola. So let's figure out the difference of distances from these 2 points, P1 and P2. On the left hand side, we have the difference of distances from P1, and on the right hand side, we have the difference of distances from P2. Let's see what we have. P1F2 minus P1F1, which means P1F2, this is the distance from the farther focus, minus P1F1, this is the distance from the closer focus. So difference of distances when we are at P1, and here we have the same thing for P2. Now as a next step, let's color code some distances. Let's make this length as green, this as yellow, and this as orange. Let's assume that we don't know whether green or orange are equal or not. If we rearrange this equation, we have P1F2 plus P2F2 equals to P2F1 plus P1F1. Let's represent both sides of this equation using our colored line segments. P1F2. So what's P1F2? P1F2 is the distance from this point to this point. That's the yellow length plus this green length. So yellow plus green. Then we have P2F2. P2F2 is this green length. So another green. This is equal to, by the definition of the hyperbola, this is equal to P2F1. That's P2F1. That's yellow plus orange plus P1F1. That's another orange. So if these two are equal, then this yellow cancels out. We have twice of green equals to twice of orange, which means green length is equal to the orange length, which makes sense. This is P1F1 and this is P2F2. This means the distance of this vertex from this focus is the same as the distance of this vertex from this focus. These two are the same, but we're not done yet. We have to figure out the difference of distances. Let's see what that is. We have P1F2 minus P1F1. So P1F2 is yellow plus green minus P1F1. So P1F1, that's orange. So subtracting orange. We have just shown that green and orange are the same. So if we subtract orange, this green and orange cancel out. What we're left with is this yellow length. And what's this yellow length? That's A plus A, that's 2A. So we have just shown that the difference of distances is equal to 2A. It's true for this point, it's true for this point. In fact, it's true for all the points in the hyperbola. So this is how we can prove that the difference of distances for any point on a hyperbola is equal to 2A. Now let's also figure out the length of the latus rectum. Latus rectum is this length. This is perpendicular to this axis. It passes through the focus. We have one more here as well. So how do we figure out the length? Well, for that, we can figure out the y coordinates of this and this point. We have the x coordinate, that's C. We can plug this in the equation of the hyperbola to get the y coordinates, and we can take the distance between these 2 points to get the length of the latus rectum. So let's do that. The equation of the hyperbola is x square by a square minus y square by b square equals to 1. Now, for the hyperbola, we have c square equals to a square plus b square. So we can replace this x with c, and c square is a square plus b square. So what we have is a square plus b square by a square minus y square by b square equals to 1. This is a square by a square, that's 1, plus b square by a square minus y square by b square equals to 1. 1 cancels out. We have y square by b square equals to b square by a square. Multiplying both sides by b square, we have y square equals to b to the power 4 by a square. Taking the square root, we have y equals to plus minus b square by a. Root of b4 is b square and root of a square is a. We have a plus minus here. This means we have 2 points. One is this one, c comma b square by a. The other one is this one, c comma minus b square by a. The distance between these 2 points will be twice of b square by a, twice of the y coordinate. So length of latus rectum, that's going to be 2b square by a.